Hi, and welcome to another video on object-oriented programming in C#. With me, Marinas Toman. Okay, so in this video we're going to look at arrays in C#. So arrays are used to store multiple values into a single variable instead of declaring separate variables for each value. So to declare an array, we define the variable type with square brackets. So in this example here, this is a string array called chars. So to insert values into it, we can use an array literal. So we can place values in a comma separated list, just inside curly brackets like this. We could also create an array of integers, so we can have different, types. But all of the data in an array must be of the same type. So an integer array will only store integers, a string array will only store strings. We can access the elements of an array by referring to the index, and this statement accesses the values of the value of the first element in chars. So the first element always starts with 0 in C#. Some other languages, an array will start the index at 1, but in C# and Java, the index starts at 0. So 0 is the first element. So this will output Volvo. So if we put in chars and access the first element, that would be BMW. So we could change a specific value of an array basically by accessing the index. So chars at index 0 is now equal to Opel. So in this example up here, it would change Volvo to Opel. So we can see ourselves that now, it's now Opel instead of Volvo. So we can find out how many elements are in the array using the length property. So if in this example we have an array that is 4 elements long, so whenever we call the name of the array dot length, then that just gives us the number 4. So this can be helpful, whenever we're looping through the array and we want to know, exactly how many elements are in it. So some other common ways to create an array. So if you didn't know, what the elements were, but you just wanted to create basically 4 string variables inside one array, this is the way that you would do it. So you just use the new keyword. Another way is this here. It's a bit longer, it's just easier to kind of use the curly braces. But these are all valid. So, like I say, if you already know, what you want to initialize your array with, you would typically use this one here. But if we didn't know, what we wanted to put in it, then we would use this one. So it's up to you which option you choose, but in this tutorial we will often use this last one as it's faster and easier to read. So I would always recommend that as well. It's just easier to read, less mistakes. So the only thing that you got to be aware of when you're doing this is, so if you declare an array here, so you're just declaring the variable, and then later on, on a different line, if you're going to declare or put values into it, you need to use the new keyword. Okay, so this example here is good when it's all in one line, but if we don't know what we're putting into it for a while, then or for a few lines, then we need the new keyword. Okay, so this here example here will actually cause an error. Okay, so that's pretty much arrays in a nutshell. So they're just one variable that can store multiple values, and all the values have to be of the same type, and then we can access different elements of the array basically through the index. Okay, so normally what we will do is we won't be accessing one thing at a time, or if we do want to access one thing at a time, we'll usually be going through the whole array. So this is where loops are really handy for this. You can loop through the array elements with a for loop and use the length property to specify how many times the loop should run. So whenever it's an array, you always want to go less than the length, because if you think about it, the length of this is 4, but if we went right up until 4, then index would be 0, 1, 2, 3. The fourth, if you used index 4, it would actually go out of bounds. Okay, so it's always a good idea to have just less than the length. Or if you're going to go less than equals to, it has to be length minus 1. Because it's always 1 smaller than the actual length, your last element. So that's basically what we're doing. We're starting at 0, and then we're looping all the way through. We're incrementing I each time, so we're just looping through each element of the array. Yeah, so if you look at that, we're just printing out, and it just loops through. So this is normally how we would access arrays. They go hand in hand with loops, because it's normally, if you're using an array, it's normally multiple pieces of data or multiple values that you're storing inside. So we looked previously at the for each loop, and this is basically explicitly for arrays. So this is easier than writing this kind of the ordinary for loop statement, because this stops us going out of bounds. So the general syntax is this: so for each type, and then you just give a local variable name for the loop, and then in, and then whatever your array name is. So instead of accessing the array by the normal index, what it does is it takes that value out of the array and stores it in this local variable, just while the loop is running. So let's say in this example, we could say have our array chars that has 4 strings, and then for each string I in chars, we just print them out. So this does the same thing, only it's a lot easier to read, and it stops us going out of bounds. So normally what you would do is say for every char in chars, because that's much easier to read. So for every char in chars, just print out the char. So like I say, this is a local variable name. You can call it whatever you want. Another thing as well that you'll see is maybe sometimes you're reading an array and you don't know what type the variables are inside. So in C# we've got this, we can use this var keyword. So basically it means that it's a variable with no type, and the type will be determined at runtime. Okay, so sometimes that's just as easy, because especially if you don't know what data type chars is, for example, if you're using an array from somewhere else, from somebody else's program. So the for each example, it's easier to read. You see, it's easier to write, and it doesn't require a counter using the length property. So there's a lot of benefits from using for each with arrays, and the main one that I would say anyway, from experience, is stopping yourself going out of bounds. Because this sometimes it's confusing to always remember that the array starts at 0. So sometimes you'll just go to the length of it, which will always put you out of bounds. So for each is easy to prevent that from happening. So one of the useful things about arrays is that we can sort them. So let's say we have a list of data, and it's all stored in our array, and maybe we want to, you know, if it was strings, maybe we wanted to store things alphabetically. So there are many methods available. So for example, this sort method, which sorts an array alphabetically. So this is an array class in the system namespace. So you know, it's in the .NET framework that we can use. So it's just a static method. So it uses the name of the class, .sort, name of the method, and then you just pass in whatever your array is that you want to sort. So you can see this works for strings, for numbers, for a whole variety of data types, and it's just really handy, you know. So originally, let's say this example here, we have 5, 1, 8, 9, and if we wanted to sort them in ascending order, then we would just do array.sort, and it would sort them in ascending order. So the same goes for, if you remember our practical on ASCII values. So what it's really doing here is just the same thing. It's converting the characters to numbers and saying what is the lowest number. So that's why B is coming up first. And usually, you know, as we know, the lower the number, then the higher it is in the alphabet. Okay, so that's really handy that we can sort our arrays. Sometimes you might be getting an array from somewhere else, some other program or some other method, and it's just a jumble of data, and maybe, you know, you want to sort it maybe before, you know, you pass through a searching algorithm, for example. So other useful array methods such as min, max, and sum can be found in the system.link namespace. So you just got to add this, you know, using system.link statement here at the start of your program if you want to use these methods, and then just these work straight on your, you know, your variable. So this myNumbers.max will return 9, .min will return 1, and sum then will return just the sum of all the numbers. So again, there's some real you know, handy, helpful methods that are available, and especially for working with arrays. And then finally, multi-dimensional arrays. So this is a bit more of a complex concept. So arrays are basically, if you think of them as, you know, like a row of data, and all of the data, all of the boxes in the row, you know, each column is its own you know, box for data to be stored. So, you know, this would be a normal array here. But what we can do is we can have two-dimensional arrays, or like a table. So if this was our normal array where we had like one, you know, row of data, then a multi-dimensional array would just be an array that stores arrays. So this example here is an integer two-dimensional array. So conceptually, looking at this in memory, this is what it would look like. You know, so the green would be an array, and then the blue would be its own array, and each array is an integer array that stores its own, you know, integers. And these are called 2D arrays, or two-dimensional arrays. And I like to just think of them as tables like this. So although it's going in, you know, like this, you can see there's a comma here between the internal arrays are enclosed in curly braces and separated by a comma, and then the data inside the internal arrays are just separated by commas. So this single comma here specifies that the array, this one specifies that the array is two-dimensional, and then, you know, as it follows, a three-dimensional array would have two commas, and so on. So you can have higher dimensions of arrays. So a three-dimensional array would just be, if you know, kind of think of this as a two-dimensional space, then your third dimension, you know, would be a stack of these. So it would be an array of arrays. It starts to get confusing, you know, when you start to nest arrays, but these are helpful data structures for us to know about. We might not use them too much, but you know, we have to at least know about them. So this numbers is now an array with 2 arrays as its elements. So it's an array of arrays. The first array element contains 3 elements, while the second array element contains 3, 6 and 8. So you can see this is the second array. And then yeah, just to visualize it conceptually, you know, we kind of think of it like a 2-dimensional data structure, just like a table or a matrix. So to access an element of a 2-dimensional array, you must specify 2 indices. So one for the array and one for the element inside the array. Or the way I like to think of it is rows and columns. So if you think about this here, we've got each array is its own row, and then each element inside that is its own column. So if you think about this would be our first array, our first row. So it would be row 0, and then this would be our third element. Okay, so that's 0, 1, 2. So what this would return would be 2. And one of the ways to remember this, I always like, you know, if you think about R and C, rows and columns, and the way to remember the order that they come in is just write R before C. So R, I, C, E, rice. So again, if you know, we can do all the same things that it's just you know, we're increasing basically. If you think about an array as a row of data, then we're just increasing the number of rows that we have. So we can access it in the exact same way. The following example is the first row and the first column. So 0, 0 is going to be, so that's the first row, the first array, and then the first column that's going to be 1. And what you can do now is set that to 5. So then when this returns, it's going to be 5 instead of 1. Okay, so you just need to, the only difference is you need to access with 2 numbers now in your index instead of 1. So if we're looping through a 2D array, what we would typically do is we would have 2 loops. So for I in numbers, so it's just going to print everything from I, or sorry, from numbers. But what we would typically do is we would have a loop for the rows or for the arrays, so that would be our outer loop, and then we would have an inner loop for the columns, you know, to iterate across through each array. So basically, if we go back to the kind of visualization, we would have an array, one that loops through each row, and then another loop that would loop through the columns for each row. But we look at that later in other practicals. Yeah, so actually here's an example of it. So you can get the length of the outside array. Sorry, of the array at, you know, position 0 of the first array, and then this is basically getting the length of, so this is the number of arrays that are the number of rows that you have, and then this is the number of columns. So basically the number of elements in each array. So if we look at this one, what if we just print these out to see what it retrieves for us. So we have 2 rows and 3 columns. Get length 0 should return the row number, so that should be a 2. That the first thing that prints out. Okay, and then if we do 1, which is this one here, that should return 3 as the first number, because that's the number of elements in each array. Yep. Okay, so you can see what these are returning. So this is going to go for 2 times, and then this is just going to run for 3 times. And remember, just always keep it less than. You don't want less than or equal to. Keep it less than, that stops us going out of bounds. And then what this does is loops through every single element and then just prints it on its own line. Okay, so that's it for arrays. Looping through arrays, sorting arrays, and multi-dimensional 2D arrays. Okay, so that's everything for the video. Thanks for watching.